Okay, we're back. Again, Dr. Chuck Kowalski. I am a S3 controller at the Jacksonville ARTCC for VATSIM. I'm also a mentor and a real-world IFR pilot. Uh, Class 4 is going to finally talk about the stuff you're probably really anxious to get into, which is some of the controller duties, in this case, the clearance delivery duty. Like all the classes, these substitute for your one-on-one going through these slides with a mentor or instructor, and the only requirement afterwards is to demonstrate a knowledge check with the mentor instructor before you go into the sweatbox. So your first sweatbox session will have a knowledge check review of all of these slides, at which point if you have any areas of knowledge weakness, they'll stop and they'll go over that with you. But generally, most people, after going through these slides, are ready to get into Sweatbox. Like most of these slides, the videos that are embedded will be put into the description, and you can play them after you watch the slides. Or you can pause the slideshow and you can play them at your leisure. So clearance delivery, we're going to talk about what that is. We're going to talk about the flight data that we see to create a clearance and additional VFR clearance concepts. Now, I want to point out that clearance delivery is probably one of the most important positions of all the controller positions. It's just the first position you're going to learn and work. And even though it has no actual movement, you're not going to taxi anybody. You're not going to clear anybody for takeoff or landing. You're certainly not going to be doing any radar control at this point. But the reason it's so important is because if you don't get the flight plan right and you don't get the clearance right, then that pilot's flight will be screwed up from the time they take off till the time they land. The controller will be correcting things because it was screwed up at the start. So if you don't get the clearance right and you don't get the flight plan right, it sort of screws up the entire flight for the pilot, and it makes it a lot harder on all the other controllers. And believe me, they know when you didn't get it right. So please pay attention on these things and work hard to become a good clearance delivery controller. There's a video in here. This video is pretty much mandatory. I'm not playing it, but it will be in the links in the description. Please either pause now and play through this, or do it at the end of the slide deck. We're going to talk about the flight data. When you're in VRC or VSTARS, you'll see this gray box, which they call the flight plan. This will contain the flight data for the flight plan. And when the pilot files their flight plan through one of the various, simulator systems, either vPilot or XPilot or Swift, then it'll come through the server and it'll show up in our flight data box. We're going to highlight some of the few components in here that matter. Obviously, the call sign. Most of these are labeled. You can tell what they are. The aircraft and type, as well as the navigation type, whether they're going to be flying IFR, VFR flight rules, the departure airport, which is in the ICAO format. There may or may not be an arrival airport if they're only going to stay in the local area. When they stay in the local area, I typically make sure that these match, just because it's easier for the software to see it that way. The alternate airport is not important. We ignore it. The cruise altitude is written out. It's not FL400. It's written out in all the letters, or all the numbers rather. We'll talk about the scratch pad at a different time. And the squawk. The squawk is what the pilot says in their transponder and what we expect to see. So on this side of us, it's what we expect to see. And when they put in their transponder, the system will tell you whether they got the right number or not. Finally, we get their flight plan down here. And then down at the bottom is remarks. This is all for simulation and for to make it more realistic for the simulated pilot, for the pilots flying. The only part of here that we'll talk about is what's between these two slashes. This is usually near the very beginning, and V here means that the pilot is using software that they can use the radios with voice and audio. The other letter you'll see in here will be R, which means that they don't have a microphone, but they can hear us, and they're going to respond by text. And a T, which means they can't hear us and they can't talk, And so they're responding by text, and we are sending text and messages to them. Okay, so let's go through these a little bit more. Aircraft type and equipment suffix. So there's a whole bunch of links that I'll put in the description so you can learn what the aircraft types are and the equipment suffixes. These do matter, by the way, that they get them reasonably correct. And so in this case, it's telling you that it's a 737-800 using the X equipment suffix. The appropriate suffix is required, and you need to have it it has to be present. So if they enter a flight data plan and it doesn't have one, you need to put one in. So a/U would say that they don't have DME, but they do have a transponder. So if they don't have DME, that means essentially they can only fly directly from one VOR to another VOR, maybe. Actually, no, with a slant U, they can't even do that. They're literally just going to be flying with no way to do navigational fixes. So everybody has to have a transponder anywhere in the system, even if they're VFR. So you'll never. So if anybody puts a /X, which means I don't have a transponder, that's wrong. And sometimes they do that thinking that they can get away with flying without a transponder. Well, they have to correct that, and they have to turn the transponder on. So there are 4 flight rules on VATSIM that we use. We have visual flight rules, regulations that allow the pilot to fly in weather conditions generally clear to see what's by the horizon. They have to stay clear of clouds or a distance from the clouds, and there has to be, depending on whether flying 1 mile or 3 miles or better visibility. And in some cases better than 5 miles visibility. And then the instrument flight rules, again, regulations for flying based solely on the instrument panel without looking out the window. Special visual flight rules is a set of regulations that allows them to fly in conditions that are really not VFR. You'll rarely see this, and the reason you won't see it is because if a simulated pilot doesn't want to fly instrument flight rules, they'll just change their simulator to have the weather for VFR, right? And we don't use this either. This is the flight rules for an ADIZ or Air Defense Identification Zone. Again, those are not really applicable in VATSIM. So in general, in VATSIM, to fly VFR, the METAR that we talked about earlier needs to show a 3-mile SM or higher value, and a ceiling, remember it said ceiling means broken or overcast, that value, the first value that has that has to be above 1,000 feet above the ground, which is going to be some value plus the elevation at that location. The departure arrival codes, these are pretty straightforward. They are whatever they are for the airfield. In the United States, everything has a K. So if you just see MCO or STL in here, that's not correct, and it will not code properly in the controller simulator. So it's important that you have the ICOA and not the American FAA code in here. So it's got to. So for the United States, that would be a K. So the altitude has the rule. In order to separate, this gets a little complicated, but we'll make it simple. Just remember that even is odd and west is even. The way I remember it is that east starts, I'm sorry, east is odd, west is even. The way I remember it is that east sounds like it ought to be even because it starts with an E, but it's the opposite. So if east, and what is east? East is anything from a heading of 0 up to 179 or 360 to 179. That's defined as east. As soon as you hit 180, it's defined as west. So when we looked at the cruising altitude, we have to look at the direction of flight for the aircraft and determine what range they're in. In this case, this fellow is going to St. Louis, and we know that St. Louis is going to the west, right? From Orlando, we don't really need a map to see that. So, knowing that they're going to the west, are they even or odd for cruising altitude? Well, you can figure out that it's even. When you're looking at the cruise altitude, understand that the decision of the direction to their destination is based on the line of sight route. So a straight line from here from Orlando to St. Louis is what defines that bearing. And it's at the origin because when you look at the Great Circle and magnetic bearings, the origin direction will not be the 180-degree opposite of the destination direction. It turns out that doesn't work that way. So we use the origin direction direct to the airfield, not counting what the route of flight is. So we ignore the route of flight. And we just go straight as the crow flies. And that's the number we use to determine if they're east or if they're west, and if they're east and odd or west or even. Now, the only exception to this rule is that people, if they're flying below 3,000 or above flight level 400, and the reason for that is, well, below 3,000, it doesn't really make sense because everybody there should be VFR or on approach or departure. So it doesn't make sense to have any separation below 3,000. But it used to be when we used radar and the angle of the radar to determine altitude, that we didn't have a super accurate measure of altitude of the aircraft as a controller. Now that we have ASDB and we have literally, we have GPS and we have very accurate altitude reporting, we don't have to worry so much about the accuracy of what we see as a controller. So before the days of GPS, anything that was flight level 290 to flight level 410 used to have a requirement for a 2,000-foot separation. Now that we have the better altitude reporting equipment, that has been changed, and they can be 1,000 feet apart. And conveniently, it also lets us nearly double the number of aircraft going in that airspace. So by changing the rule, and it's called the reduced vertical separation minimum rule, by introducing that rule, it makes it easier for us as controllers because you just have to remember even or odd up to flight level 410. And the pilots, we can get more planes into the air. And in the real world, the pilots can choose more altitudes to avoid turbulence. So they have to have certified autopilots and altimeters for this, but in VATSIM, they just have to have their equipment suffix to identify that they are using one of those higher quality reporting units. So if you go above flight level 410, the rules change and the separation is every 2,000 feet. And we'll talk about that. So here's a good picture of it. Before it was weird, it was 2,000 foot separation. So at 410, they would be going one direction, and it was, so let's go to the bottom. From flight level 290, they'd be going one direction. It would be 2,000 feet to go the other direction. Now it's just every 1,000, which gives us more aircraft to go to get in there. But when you get above 410, you start doing the every other rule again. So for ICAO rules, if we say that 410 is odd and we're going to therefore be east, that means that since 2000 above, 430, which is odd, you'd think it would be east, but no, because we're doing every 2,000 feet, 430 is for the west, or 180 to 359. and then alters again. So 450 would be the east, 470 would be to the west, and so on. We do have VATSIM pilots who fly aircraft that can go that high, so remembering this little detail is important as a clearance delivery person, because you got to get the right cruise altitude to put in there, so that when the en route controller gets them, they are assigning them at the correct cruise altitude. Now, your en route controller knows these rules and will correct it, but it's much better if you get it right at the beginning. So let's dive into the parts of this particular flight route here. It says ZJX to Mateo, direct to VQQ, and then on Airway Tango 207, etc. So we're gonna do it by the numbers. So the one in this orange item is actually their departure, and you can tell a departure because it typically has a number attached to the end. So this is the Orlando JAG 6 departure, and what a departure is, or standard is a standard instrument departure, and there are another type called an obstacle departure procedure, but we're going to skip that one because we don't have too many of them in Florida. The standard instrument departure is how they get out of the terminal area, and it has pre-planned procedures in it. Why do we have them? Because all of the flight plan is designed for what the pilot is expected to do in the event of lost communication. So we can deviate them as controllers from their flight plan, and they can request deviations from their flight plan as long as we have two-way radio communications. But if those communications are lost, then the pilot is expected to adhere to the flight plan that was filed. So that's the JAG 6 departure. You can look it up in SkyVector or AeroNav and see what it looks like. So once they fly out to whatever that departure is, there will always be something called a transition. And transitions are the exit point of the departure, and transitions are the entry point of an arrival. And they are indicated on the chart, and they're, as you can see in the red box here on the image, that there is an ALMA and a Baxley transition. And then they have that on the chart at the top. Now remember that these charts are not accurate to scale, so they'll squish the lines and move them in order to get a good picture for an understanding and still fit them on one page. Now, even though they have a published transition, the pilot can leave the departure at any point along this procedure. So they could leave at Arnie, they could leave at Baxley, they can leave at Alma, or they can even leave at Kimmel. But typically, that would not occur without two-way communications. And by the way, you don't have to have a transition. The Arnie 2 departure has, Baxley and Alma, but they could just as easily, the Arnie 2 departure could have stopped at Arnie and not had anything after that. So what's the difference between that and an obstruction departure procedure? Watch this video to see. No, make it simple. Now, there's three kinds of standard instrument departures. So this is called a pilot NAV SID. And in a pilot NAV SID, the key thing to realize is there are no radar vectors. The entire route is defined in this SID. So the pilot is going to take off from a runway. They're going to fly according to the instructions to the various waypoints until they get to their transition, or their flight plan exit point, whatever that may be. And it's defined in both on a picture and it's defined as a written description. You know what the departure altitude is because it's sitting there right on the chart. And this is typically the one that you're going to give in the clearance. We have SOPs that define this, but in our SOPs, we're usually using the top altitude of the SIDs as definition for those initial altitudes. So in this case, if the pilot were to lose radio communication, we would expect them to fly the pattern that's drawn out on the map and follow the instructions in the description. In a radar vectored SID, you can see that there are no pilot routes. Okay. All we know is that they're going to be taking off and going to the first point on the SID. Now, you can see that there's a bunch of VORs on here with a typical VOR nameplate, and also the latitude and longitude if they're going to use that, if they're going to do it by GPS. But normally this is a radar vector. We vector them towards whatever their exit point is. Also, it's not required that they choose one of the VORs or waypoints that are on the map. As long as they fly a climbing, follow the description, and get radar vectors onto their route, that's good enough. So these are basically a get out of jail free card in that they can, as long as they take off on the heading and climb to the top altitude, they're good. Whether or not it's actually one of these VORs or something else depends on what the flight plan says. So then there's also hybrids. And a hybrid is just what it suggests. It's a combination of radar vectors and then following a pattern. So the Llama 7 SID at Daytona Beach is a good example of that. They're going to take off on a various heading. They're going to climb on that heading until they reach 4,000 feet. Or, unless ATC gives them something different for radar vector or altitude. And then they're expected to fly to intercept the Bitho intersection. So when they take off, they're going to join this radial off of Bitho. So the solid line part is once they take off and get on this line, we expect them to follow this line. And what this is also showing you is that you can use a waypoint in your GPS, or you could use a couple of VORs and intersect know what the intersection is. Set the Ormond Beach VOR to radio 176. Set your second VOR or NAV to Ocala at a radial of 099. And when those two VORs both hit the center point on the bearing selector, then you are at that intersection. So you don't need to have RNAV to fly this type of departure. You can be a slant alpha with 2 radio navigation, or you can be a slant alpha with 1 VOR, but it has DME. So you could have radio 176, but you know what your DME is, 17 miles. So you could set 1 VOR to that and hit that waypoint, and you'll still get to Llama. So there's a variety of ways that they can navigate to go out on this type of SID, which makes these very welcome types of SIDs to the general aviation pilot. So can you identify the type of SID Southwest 2702 is flying? I'll pause for a moment. If you said that this is a hybrid SID, then you are correct, because they're going to take off and they're going to follow some type of radar vector or assigned radar vector. And typically here, if they're taking off to the south, they get radar vectors outside of the arrival lanes, and then we tell them to go directly to Guano, and then they're expected to fly a line from Guano to Mateo. So that's the pilot control part. So this is a hybrid SID. Oh, and here's the answer. I'm so glad I got that right. And you can see it in the description. It tells you both. tells you the radar vector, tells you then the pilot NAV SID. Let's talk about airways for a bit. There's a lot of airways in these various flight plans, and the airways are changing. So depending on the cycle AIRAC that the simulated pilot is using, they may or may not have the most recent airways in their simulated computer. For that reason, we're fairly lenient on the airways that they select. Because they may be using a prior cycle where that particular airway no longer exists. But we'll still let them fly that airway. And I can tell you as the flight engineer for Jacksonville, we keep those airways in the controller software for you so that you can see them if you have to. There are three types of airways. There's the high airway, the low airway, and the RNAV airway. The difference is, as you might expect, the low airways mean that the VORs used for those airways are low, typically below, I think it's 10,000. Someone will correct me if I'm wrong. And high is, no, I'm sorry, low is below flight level 180, and high is above flight level 180. Can a pilot fly a low airway and be above flight level 180? Think about that. If you answered yes, you are correct. So you can fly a low route airway, but how you put in the flight plan is a little different. You can't actually put in the low airway title like Victor Airway. But you can put the VORs, provided those VORs are also certified for high altitude. So, and I've had pilots do that where they wanted to fly above flight level 180 using the VORs, and they put in the string of VORs that followed that low altitude airway. And then you have the RNAVs, which most of us are familiar with. The RNAV airways are just what they suggest. They're GPS waypoints. So the low altitude airways serve below flight level 180. They start at 1200 AGL. They're called Victor Airways. The FAA actually plans to eventually sunset the Victor Airways. I don't know how soon that'll be, but they're going to do that in favor of the RNAV Airways because the RNAV Airways gives them a great more flexibility and use of airspace. The VORs, as you know, are rather bulky buildings. You can't just pick them up and move them somewhere else. They have issues that their distance measuring equipment is based on the angle from the ground to the altitude. So it's not an actual statute mile distance, it's a slant angle distance. They also have an issue of something called the minimum safe altitude. And that's the altitude that aircraft can fly safely on the airway. And that'll be marked on the airway typically. That's usually due to ground obstacles. So when you're controlling and they want to go along an airway, as a controller, you can't clear them along the airway if their altitude is below the MSA for that on the chart. So high altitude en route charts can also have minimum safe altitudes, by the way, because we do have mountains. So, okay, for the high airways, these are usually called jet routes. We did have Q routes. The Q routes are going away in favor of jet routes. Again, we keep them on the simulated software for the folks who don't have current charts. But generally, these are going to be the airliners, turboprops, things that normally fly above the flight level 180 in Class A or Alpha airspace. These high airways go all the way up to flight level 450, and they will typically have a J or Juliet prefix. Now, like I said, they can't technically use Victor Airways above flight level 180, but they can instead substitute the VORs that have high altitude certification. The RNAV routes are exactly what they say. They're no longer based on the VORs. They're based on GPS coordinates. And the RNAV routes On the low routes will be T. The high routes will be Q. I think I just misspoke when I said that the Q routes are going away. It's the other way around. The VOR J routes are slowly going away in favor of the high altitude RNAV routes. Navigational aids fixes are what allow them to fly with the navigational equipment or GPS. A fix is sort of a generic term for anything. So a VOR, a non-directional beacon, a DME, which is a VOR with distance measuring equipment. A TACAN is a military version of that. And of course, navigational fixes or GPS fixes. All of those are considered fixes in general. So let's talk about VORs a little bit more. These are big buildings on the ground, and by having these collimators at the top, then the signal coming off of the antenna at the center will collimate so that it indicates the radial that the aircraft is seeing from that particular VOR. They all have a name as well as a three-letter identifier, and the name does not always match the three-letter identifier. So VQQ is Cecil, for example. So the only thing a VOR does is tell you the radial you are from the VOR. It would have to have additional equipment on it to show you how far you are from the VOR. Let me go back and point one other thing out. On the map, it'll tell you the VOR, the name. It'll tell you the three-letter identifier, the frequency you dial into your nav radio to catch it. And then because this frequency has a subtone on it that's constantly transmitting the identifier in Morse code, for those people who don't know Morse code, they actually draw it out for you. V is da-da-da-da, Q is da-da-da-da. So it'll be da-da-da-da, da-da-da-da, da-da-da-da. It'll pause for about 5 seconds and then I'll do it again. And that's very helpful to the pilot in the real world if they want to know if their VOR receiver is working and capturing the VOR. Because if you can't hear the Morse code, then it's a good bet that you're not capturing the signal or that the VOR is out of service. So a non-directional beacon is what the original fixes were. And in the original days, it wasn't even just a beacon that was sending out a signal. It was actually an AM radio station. And if you knew the location of the AM radio station in town, you could turn your non-directional beacon to the AM radio frequency. And even today, you can turn your non-directional beacon to an AM radio frequency and listen to the AM radio while you're flying along, provided, of course, you're not trying to use it for navigation. There's typically only 2 letters for a non-directional beacon. And again, the name doesn't have to have anything related to the 2 letters. And because it's an AM frequency, it only has the hertz that it's on. So this is on 341 hertz. Now, NDBs don't send out radials. So how do you get the direction? Well, your antenna is a circle. And the circle is, if you have the ability to do it, you can turn, sometimes they have a motor on it, and you can turn the antenna. And the turning of the antenna will tell you the degrees offset from your direction of flight. And you can use that to figure out the direction for the NDB relative to your airplane. Now then you have to go do a little mental math based on your direction of flight and the offset of the radial to figure out what the actual bearing is to that NDB. For that reason, a lot of people don't like to use NDBs, but it's a lot of fun to practice even on the simulator to fly by an NDBs. So here's a DME antenna, and this is always tied to a VOR. When they abbreviate it in the text data that we use in our simulator, they just call it a DME. It's assumed that people know that it's a VOR slant DME. On the charts, it will often have VOR slant DME. So you can't tune a DME directly. You have to tune the nav aid and with the DME attached to it. And this is simply a Doppler signal that goes back and forth to the DME, and the time it takes for it to go back and forth calculates the distance for the time it took for the signal to hit the aircraft and go back to the DME. It is affected by the angle of your altitude, so if you are higher, it will say you're farther away. If you're 12,000 or 11,000 feet in the air, you'll still say that you're 2 miles from the DME, even when you go directly above it. So a TACAN was used by the military, and it's very much like a VOR and DME. It's just more accurate. And they are also mobile. So these are used in military environments, and they can set a TACAN up anywhere they want. They put it on the back of a big truck, roll it up in the middle of the field, and the truck lifts it up and straightens it up, and they put some guy wires on it and attach a generator to it, and Bob's your uncle, you got a VOR DME. For that reason, we don't normally use TACANs unless they're fixed, and the FAA identifies them. So navigation routes, we talked about these. These are 5-letter fixes consistently. They're always 5 letters. Because they're 5 letters, they can have phonetic sounds to them. And controllers who plan these GPS fixes have a great deal of fun creating clever 5-letter combinations that we can talk about and say out loud. So since we're in Orlando and we have all the attractions around, they were able to give us some Disney items here. So we have Piglet, we have Tigger, we have Rafiki, we have Jafar, we have Jasmine, we have Mtara, and Hakuna Matata. So as you're flying along this arrival, you cross Hakuna to Matata. Then you see Jasmine, Jafar, and Rafiki. So it's just sort of fun that they do that. And some of them can be very entertaining. If you Google this, you'll see there's some really great arrivals combinations. Finally, the arrival, the standard terminal arrival, or STAR, will be when they highlight in orange so you can see it. And again, these are going to be some name. They're typically longer than SIDs. They do have a longer name to them, and they still have a number at the end of them. And the number does indicate the version. So at one point there was a Boosh 1 that became a Boosh 2. Strangely, by the way the weird nomenclature rules work, they could potentially get a Boosh 3 and then go back and start with Boosh 1 again. It's because of the weird ways that they name these arrivals. The way we know they changed them is that the name changed. And Howard and I, as your engineers, keep track of that sort of thing on every cycle. So you'll always have the most current arrival information on your software. So that's how the arrivals work. We saw the SIDs. The stars look the same way. The stars can also be, generally the stars are all entirely pilot controlled, but they can be a hybrid at the end where they get the person. Let me just go back to that picture. So here, when we look at this chart, you can see that sort of is always a hybrid, because when you get to the end of arrival, some sort of direction or radar vectors is required to line you up to land at either, in this case, it's showing Orlando International. So if you're landing to the north, you go down to Kewah. If you're landing to the south, you go to Honor. So they're all, we don't call them pilot controlled or hybrid, but recognize that almost all the stars are some type of hybrid. Okay, so hopefully you can see the entire route now on this particular flight plan. You can see they take the JAG 6 departure, which contains guano in it, and then they go to Mateo, and then direct indicates that there's no airway or path, but they're going to fly directly to the VOR, and then they're going to get on the various airways. And when they finally get to Birmingham VOR, they're going to enter the Boosh 2 arrival. You need to make sure when you're doing the clearances that particularly if you're going to change the clearance, that the VATSIM pilot can accept the route that you're doing. Uh, so if they say that they can't do fixes, for example, then you may not be able to do the boost to arrival. We know that they could get away and do the JAG6 and they could fly these VORs and these Airways without having fixes. But you'd have to look at the boost 2 and make sure that they can fly the fixes associated with that. If they could not take fixes, for example, they would not have been able to take that piglet arrival you saw earlier. Also, there are preferred routes between airfields. Again, I use SkyVector. You can use AeroNav, or you can use the FAA published preferred routes. I think that's the hardest way to do it. So, and those are typically between very large airfields, although the FAA is adding them for a number of airfields, even the not so large ones. And the way you do that is if you go to SkyVector, put in the origin airport and the arrival airport, and then just put in something close to the altitude that they're going to be flying at. It doesn't have to be exact. And give it a moment, and then the routes link will show you all the routes, and it will identify the preferred route for that particular airfield pairing. So we talked about the transponder squawk code, 4-digit octal number. That means it goes from 0 to 7. It's base 8. This is what they put into the transponder, and this is what we expect to see. And if they don't match, your VRC or VStar software will tell you they don't match. There's a few specific ones that we use all the time. 1200 for visual flight rules. In Europe, they use 2000 for instrument flight rules. We don't use that too much in the United States, but the simulators will often start at 2000 as a result. We do not allow people to use Squawk 7500 in VATSIM. So never allow that. If they don't change the squawk and they want to stay on that, that's a dot wallop that your controller will take care of, which means calling a supervisor who will determine whether or not the pilot should be disconnected from the network, or simply advise why, given some rules retraining. 7600 radio communication loss. That's not an unreasonable thing for a pilot who previously had put on that they were on voice, and now something broke on their system and they can't do voice. They can squawk 7600 temporarily until they get on text. That's okay. And if 7700 for general emergency, pilots have used that. We'll talk about that more when we're talking about controlling, but generally we're not obligated to follow along and pretend about the general emergency unless we have the time to do so. So before entering clearance, you need to check a few things. And again, if you go from left to right and work your way top to bottom in that order, you'll be able to do all these very quickly and easily. So, are the arrival and departure airports correct? Did they set up IFR or VFR correctly? And if they are VFR, does the METAR support it? Now, the other thing we'll talk about is, we didn't emphasize this, if they're on VFR, remember that their altitude is the east or west rule, so that rule still applies, but then we add 500 to that value. So VFR altitudes are the east or west rule plus 500 feet. Does the route take them to where they intended to go? And I have seen people change the airfield and not remember to update their flight plan. So hit that little plot button and zoom out and see if it's taking them to the airfield that they intended to go to. We talked about altitude being correct for directional travel. It's probably the most common correction you'll make. The easiest way to do that is either just to change it or to tell the pilot that we need to correct their altitude for the direction of flight, and can they accept 1,000 above or below the one that was wrong. Do they have the correct equipment suffix in the flight plan? Again, go back and look at that list of equipment suffixes and look at the particular ones that are needed for the revised flight altitudes to make sure they have the equipment types to fly above flight altitude 290. And then, did they remember to set the transponder code in their airplane? Sometimes you need to change something, and that's called an amendment. Uh, the pilots can also ask for an operational request, which is to change their flight plan for some reason. Uh, they can even ask that, even request you for the local weather. And that's what they're called, operational requests. Additional VFR clearance concepts. This is a long list, isn't it? Long slide deck. So VFR on top allows an IFR airplane to fly into VFR conditions and fly at an appropriate VFR altitude. A good example, and this has happened to me, is my little airplane that I flew had a maximum performance altitude of 14,000 feet, and rarely could it actually get there because of the weather conditions. So if I was IFR in the clouds at 12,000 feet and I was just scudding the top of the clouds, I would ask the controller if I can go to VFR on top so I can take an extra 500 feet and just get out of the clouds. That would be a great example of requesting a VFR on top request. Uh, the lets them fly VFR, and at that point they can fly, around the clouds and just maintain the legal separation away from the clouds. You'll notice, by the way, that the rule is 500 feet above, and that's why it says 500 feet above on the VFR rule. So you can use this. It's also used if you have to fly through a cloud layer to get into some VMP. Well, I just said VMC conditions. So you'll never see somebody use VFR on top unless they've already been IFR, right? Because otherwise you would need to be IFR. And we'll talk about that a lot more in TRACON, but just a lot of people ask about VFR on top and they somehow want to put it into their clearance. That's not where it goes. They'll make this request en route. VFR Flight Following is really common on the VATSIM system. They want to talk to air traffic control, but they don't want to be restrained by the specific en route requirements. So you'll commonly see that. Or they want to fly, they just want to use their Microsoft Flight Simulator and look at the cool scenery and just fly wherever they want to. So that's really common. The controller in TRACON or en route is not required to provide VFR flight following, although as we said in the very first lecture, not required doesn't mean they can just say no to anything. They have to have a reason to deny the request, like they're too busy in order to provide the additional services. So generally we will approve it. There's not too many times we will deny it. On the ground, you need to still fill out their flight plan. Particularly, we want their aircraft type, equipment suffix, the VFR altitude they hope to be flying at, the destination, and requested operations. What that means is, do they want VFR flight following? Do they not want it? Are they going to be doing something else? So it might just be flying pattern work, something like that. Depending on the airfield, they will get a squawk code and departure frequency. Sometimes that'll be a VFR squawk code, but most of the time we'll assign them one. And the departure frequency is only applicable, of course, if there's radar coverage or if they're in an area that requires radar coverage. So we'll give them the departure frequency, but they don't have to stay on it necessarily if they are not getting flight following and they're not in an airspace that requires two-way communication. So Class Bravo operations, we talked about this. B for busiest. Two-way communication mode, C, and explicit clearance. So when you're controlling or doing clearance, rather, in Orlando Bravo, you have to explicitly say that they are cleared into or through the Orlando Class Bravo airspace. You can say into or through the Class Bravo. It's a convention for us that we add the word Orlando. That's not required in the 7110 phraseology. The only time you receive an explicit clearance for VFR aircraft is when they're coming into a Class Bravo. And since they're taking off from Orlando International and they're on the ground, they need a clearance to take off into the Bravo because the airspace goes all the way to the ground. If they were in Orlando Executive, for example, where the bottom is about 1,600 feet, of the class Bravo, excuse me, then you would not have to explicitly give them a clearance into the Orlando class Bravo. In fact, if they don't need to enter it because of their route of flight, and you're doing clearance in Orlando Executive, you're very likely going to tell them remain outside of the Orlando class Bravo explicitly in their flight plan. So when they're clearance, in order to, because you know that they don't have to go into there, and they're so you're telling them you're not cleared to take off and go into the Orlando class Bravo, and that is the more common thing that occurs in Orlando Executive. In fact, we rarely give them, even when they have an IFR going into the class Bravo, we typically clear them to take off on a specific vector off of the airfield. And once they're in the air, the Orlando TRACON controller explicitly gives them entrance into the class Bravo. So, by the way, what that means is that when you give them a clearance in Orlando Executive, you don't blanket say cleared as filed. So you'll say cleared as filed, remain outside the Orlando class Bravo. So it means that you're cleared, but you can't go through the class Bravo when you take off. Finally, that's the end of class 4 for the Student 1 class. I hope it was helpful to you. Again, if you have any questions, please bring them up with your mentor or instructor. Be sure to pick up those videos that are attached and get the additional information there so that you're fully prepared for your first white box session. Thank you very much.